But just a little bit about what we're going to be covering today. We have Matt Malin and Justin Green from the
And
USIP,
Taylor.
and Taylor, of course, yes. Um, they were the NASA like mentors for the USIP project, like we were talking about a little bit last week. And I know I've heard a lot about you guys and all the good feedback that you've given to the USIP team and just the aerospace club in general, as well as I believe Justin, you were in a design review with the AXP team in the spring last year, I want to say. But yeah,
That's correct. Yeah.
I don't know who wants to go first, but would you guys like to say a little bit about like what you do at NASA and kind of what got you to this position?
Sure. I can go ahead first.
Okay.
Well, I guess all three of us are actually graduates from the University of Nebraska-Lincoln, but I was long ago the president of the Aerospace Club and was an officer for several years. Uh, Started a few teams for the engineering competitions, such as when it was at the time Lunabotics, and then it's robotic mining competition now, and then team lead for USLI and um, IREC with the rocketry teams. So long ago, that's what I did. And then after I was president and team lead, I was around as a graduate advisor for several years. And from there, I've continued to work with the RockSat and um, it's AXP, correct now?
Yes.
So um, the several incarnations of that I've worked with and been a team lead of that as well in the past. Um, and then I started working at uh, NASA Langley as an intern, and then I started at Kennedy Space Center as a pathways co-op and prototype development. Then I got hired at NASA Langley full time um, in the structural mechanics and concepts branch here. So I work in hypersonics, such as heat shield development, um, mostly in the materials side, and some work in scramjet combustors. Then I'm also the other half of my time is in in-space assembly. So two very different things, but they're both pretty cool. And in-space assembly, we're looking at currently assembly of large structures in orbit, or as well as on the surface of the moon. So right now, my current focus is scramjet work and robotics on the moon.
Cool.
Yeah. Very interesting. And I guess Justin, if you want to go.
Sure. Yeah. So I started at UNL, my undergrad in 2005. I finished in 2009 with my mechanical engineering degree. During that time, I had a couple internships at NASA Langley. So did a couple projects there in 2008 and 2009. And then that got me talking with folks there. I worked a lot with my contacts trying to desperately get a job at Langley. A graduate student position opened up there through a local institute called National Institute of Aerospace. So I worked on my master's degree, started at University of Virginia through distance education. Did that from 2010 through 2014 when I converted over to the co-op, the newish co-op program called NASA Pathways, and did finish my master's in mechanical and aerospace engineering degree, and then worked on my PhD as well. And I finished that in 2019. Then I fully converted over to full-time civil servant in 2019. My background is I kind of have a meandering path. So I'm mechanical and then over to aerospace, kind of carried over a little bit of controls. Then I dabbled in high performance computing as well. So a lot of programming in parallel computing, CPUs and GPUs. Most of my bread and butter is doing flight mechanics simulations. So I don't know how many of you have heard of the program Kerbal Space Program, that game. So I don't play that game, but my job, I do trajectory simulation. So a lot of what that kind of does, most of that game I think is orbital mechanics. I do most of the in the area of going from the planet to orbit or from orbit back down to a planet, whether that planet's Earth, Moon, Mars, really anywhere. I'm on a project right now that's looking at Neptune. And so I incorporate models, whether that's aerodynamics or a guidance routine or controls or mass properties or whatever, all together in this one huge simulation, and put it together and run it and evaluate different technologies. And so the technologies I've looked at are an inflated heat shield technology, kind of like inflating like an airbag instead of having a rigid heat shield for reentry. So the purpose of that is to decelerate really large payloads that just aren't possible with rigid heat shield technology. Done a lot of that work. Done some Mars entry, descent, and landing work, or EDL work. Right now, I'm on a project looking at Mars sample returns. So Mars 2020 that just launched, that'll be landing soon. That's going to cache specimens on the surface of Mars. And then I'm on the follow-up project that's going to launch another rover over there, collect all those samples, and then send it back. So I'm on the EDL piece, or entry, descent, and landing piece of that. I'm part of the Human Lander Space Program as well. So Artemis, sending people to the moon again. I'm working with contractors, so SpaceX, Blue Origin, Dynetics, helping evaluate their technologies for doing the deorbit descent and landing, since there's not an atmosphere there, not really. Doing those portions help to evaluate their technologies and inform higher ups at NASA, what's the efficacy of these different technologies and the different contractors. I've been doing a lot of early technology development work as well, from trying to use high performance computing on board a vehicle on doing entry, descent, and landing, to I'm on 2 projects right now. One for early technologies, which is looking at when you measure something, you don't necessarily know that you know a number. You have no number plus maybe some uncertainty to it. It's kind of plus or minus this much. And so there's a whole field trying to better understand those uncertainties. And when you measure something with lots of different tools or different tests, how do you bring that all the way over to say, this is the number with this much uncertainty? Trying the techniques to do that, which is using machine learning techniques and all sorts of other stuff, to another technology that's looking at using essentially, I think it's kind of crazy, magnetism to decelerate the vehicle. So since you're during reentry, you're creating a lot of heat. You can excite the gases around the vehicle. Essentially, you're making plasma that's going around the vehicle. And that plasma, you can use electric currents to generate a magnetic field, which then creates a force on the vehicle to try to decelerate it. And so they're looking at what do we need to do to try to develop that kind of technology to really be able to put it on board a vehicle to try to slow it down. And we're hoping to get forces on order of aerodynamics, which would be pretty significant. So that's kind of my career path a little bit. And I've been helping out with this group for, when did we start, Matt? It's been a while, maybe 4 or 5 years.
I think about 4 years.
4 years, yeah. So it's been kind of fun to see you guys. Every project that I witnessed you guys work on, it's getting better and better and better. It's always been really cool to see that evolve. Mm-hmm. So I'm definitely interested to hear what you guys present today.
Certainly. Yeah, and so last week, Beth and Taylor were on the call again, but I know we have some members from our team that weren't able to make it last week. So Taylor, you did a great introduction of yourself last week. Do you want to say a few things this week as well? I believe you're muted, Taylor.
Yeah. Haven't had coffee yet, working on that. Hi, everybody. Yeah, for those of you who weren't on the call last week, my name is Taylor Curl. I was really lucky in that Matt and Justin were mentors in the same way that they're going to be mentors now. when I was team lead of USIP and RockSat. And so I'm really excited to see them, and I'm excited to be a part of their group on the other end of this. So that's all really exciting. I work at a company called Maxar Technologies. We're actually one of the industry partners with NASA that Justin mentioned, working on the Artemis program. My company is building the power propulsion element, PPE, for Lunar Gateway. So I'm on that team. I'm on the program management team for that. I'm also working on 2 other spacecraft, one with NASA, JPL, where I'm the lead propulsion engineer, working on an electric propulsion system that's going to the Psyche asteroid. So it's a deep space mission, and the first time that type of propulsion is going to be used in that environment. So that's very exciting. And then I am also a lead guidance, navigation, and control engineer on a modular spacecraft build that my company is working on. So those are my big projects, but my background is mechanical engineering. I worked on RockSat and USIP and all sorts of projects with Matt, but most notably USIP and getting that team set up. So I'm just really excited that things are continuing on and that I get to be a part of it in this facet now.
Certainly, yeah. And so thank you, Matt, Justin, and Taylor for the introduction. But hopefully we have, a good PDR put together where we're able to get a lot of good feedback. But I believe, John, you were going to share that, right?
Yeah.
Okay, sounds good.
You all can see this, right?
Yep, I can see it.
Cool. So this is our preliminary design review. Our team name, if you didn't know it, is Big Red Satellite. And this is our beautiful logo that we have put together. Just a little bit of an overview about what we'll be going over today. So we're going to start with our mission. That's going to include things like our mission statement, our goals, what we hope to get out of this PDR specifically. Then we'll move on to the actual specifics of the design, and we'll start getting into what our payload is. And finally, we'll finish it off with some management stuff. So I believe we had everything kind of split up at least a little bit. So who's going to talk about the PDR feedback goals that we want?
Caleb.
So from this PDR, we want to learn what problems we may come across throughout building our CubeSat. And we want to have people like you guys with the knowledge to help us get through those problems. We want an outside perspective to help us see things in ways we haven't seen them yet. And we want more problems and possible research paths that we've overlooked to see if there's stuff that might get in the way later. We want feedback not only on our design model, but also on our general presentation readiness. And we want feedback on how we can show that we belong here and how we can make our claim in the aerospace community.
Mm-hmm. Yeah, so keeping those goals in mind, let's move forward to the mission part of it. So who's going to talk about the mission part?
I think, Dylan, you worked a little bit of stuff around there. Can you share that?
Sure. Dylan, you're muted.
Yeah. So I did not work on this, but I'll share it anyways. So basically the University of Nebraska-Lincoln wanted to make we're making a demonstration of perovskite solar cells in orbit, especially from light collection on ellipse sides. of the orbital path, and we are comparing solar panels to perovskite cells in orbit with that will like give a direct way to verify benefits from one type of panel over to the other.
Mhm. So more like this is more specifically our mission statement. I don't remember
This
who
is Caleb.
this one, Caleb again.
So our goal would be to see how well perovskites compare to the current solar cells used in space, as far as energy production and light consumption. Based on past research, they're very weight power efficient, so they weigh a lot less, which is very important on space missions, and they produce more power than actual solar cells. And they have the ability, or there has been research suggesting that they can produce power in low light, possibly even on the dark side of the Earth, which is something we could test throughout our orbit. Another benefit would be to recreate the previous testing. So in Germany, like last year, they did some testing, launching it to near space or near orbit, and we could recreate that to see how accurate their results are and get our own. We would have longer exposure to Earth to space than they did, and we'd be able to test more like radiation on it. One way that we can get this done is because we have very immediate help that we can contact quickly to get us what we need if we need it. We'd also be helping in NASA's goal to release something or to launch something from every state. Nebraska and North Carolina are two of very few that haven't launched yet. So we would make one less state that they haven't launched from. And by doing this, we want to inspire people in Nebraska to know that they have a career path outside of the stereotypical agricultural field, and that they don't have to become something in that field.
So I'm pretty sure I'm doing this one. So basically the importance of perovskites on Earth is that they're like smaller and a lot more thin. As it says here, they can collect power without being in direct sunlight. So that means that if it's on like a rainy day where most other solar panels will make no power at all or little to no power, this one will still collect some power, and maybe even at night it will collect some power. It also is flexible, which means that you can put it on curved sidings. So that'll help with like putting it on buildings that are like cylinder shaped and that type of stuff.
Who's going to cover the objective slide?
I can do it if you want.
Yeah, go for it.
Okay. So our objective would to be transmit any information we want to the ground. And maybe we're working on like making a web, like sending information between CubeSats with Florida and North Carolina, and eventually expand it. And for the payload, we want to see how the perovskites, or whatever you call them, stack up in efficiency and lifetime in the space environment compared to the regular solar panels.
Mm-hmm. Robert, I think this slide was you.
I think it was. Okay. So we would be expecting results like we would want to communicate between the CubeSat and the ground and between the 3 CubeSats, as was already mentioned. And for efficiency, we would expect it to be at least 28% efficient. And lifetime, we'd hope it lasts the lifetime of the mission.
So who's going to tackle the risks and requirements?
If no one else is gonna, I can.
Yeah, go for it.
Okay. The risks and requirements of this mission are the launch conditions. It's a vertical launch and it needs to reach the target velocity to maintain orbit. Once orbiting, the atmospheric drag, the thermal radiation, tidal effects, and temperatures can vary by hundreds of degrees. And we also need to worry about limiting orbital debris, fluids being contained, and needing to burn up on re-entry.
Who made this slide yesterday?
Yeah, I think who made this slide yesterday? I think they might not have been able to make it to the meeting today, so I can cover this a little bit. So
Okay.
really kind of our objectives to align with NASA and how we're going to reach those. So with yeah, with the CubeSat, we're going to be able to access space at a lower cost. That's really the advantage of a CubeSat over a larger satellite, but still be able to get that orbit and that long-term exposure in space. We're going to be able to develop technology that currently, I believe, is at a technology readiness level of 3 or 4. So still fairly early, and hopefully we're able to kind of expand upon that technology readiness level. So we're hoping to, work as a team, both the middle school, high school, and university students, really rely on each other for some support to, discover, what we can do as a team, what the capabilities of the solar panels are going to be, really kind of expand that current technology readiness level that we have, as well as, the perspectives of all of us within aerospace and STEM. And hopefully some of this will tie into, solar panels that can be brought back down to Earth. Because we're doing research in space, but that research can probably still be applied. And the general, use of solar panels and really enable that to be able, hopefully do some of those next steps of research for enabling these panels to be used on future spacecraft. So we're still a little bit in the planning process on how we're going to meet these objectives, but we hope to really try and prioritize the goals of the CubeSat launch initiative to make sure that we're able to meet those educational goals as well.
Absolutely. So now just kind of moving into more what perovskites are and how our payload is going to be designed.
So perovskites themselves, the mineral of it is calcium titanium oxygen 3. And for the perovskite structure, it can be made out of a few different things. So how you figure that out is you combine something from column A in the ABX3 table, if you see the picture, with something from column B and something with X3. So you can have like organo lead trihalidide perovskite. And perovskite compared to regular solar cells so far, perovskite right now have about a 6% increase in efficiency than plain silicon solar cells. Perovskite can absorb blue and purple photons. Regular silicon cells can't. And perovskite require about half of the material to make them. Yeah, they require 50% less material to make than regular silicon solar cells, which makes them cheaper and better for the environment. In this chart, it shows the perovskite's quick rise in being just good for solar panels. In 2013, they were first used as solar cells, and since then, I guess now, if the chart were to be updated, it'd probably be at the top, since they've reached 28% efficiency.
So the other bits of research we have to do, basically we need to look into encapsulation and what are the most effective ways to encapsulate the perovskite. We also need to look into how we're going to fold it, and how we are going to unfold them without risk of mistakes. And we need to look into the radiation and temperature protection and how it will work in extreme temperatures and radiation.
Okay. On our journey to go to space, we're going to have to test some things, and in space, of course, we're going to test other things. So for lifespan, we want to test how long the battery, the solar panels, and the CubeSat can last in the environment, and how fast they decay. On Earth, for efficiency on Earth, we want to like run experiments to see like what their efficiency is. And then in space, we'll measure like the amount of energy they collect with time in space to see like if their efficiency goes down the longer they spend in space. And we want to work with solar companies and ask them questions to determine like how they calculate that. For radiation decays electronics over time, so we'd want to find a way to protect our CubeSats from that. Luckily, since CubeSats are in low Earth orbit, they are protected from most radiation, and also from what I've researched, the solar panels have a good protection from it. But we don't want like our panels to lose time from radiation. So if we could find a way to block it, that'd be helpful. Next slide. Okay. So then temperatures in space, I'm sure, as you know, can get to extreme highs and low. So we would want to test on Earth to see how hot and cold our solar panels can get before they like experience decay. So if we could find a way to like control the temperature, or at least like get it to a certain range, that wouldn't be devastation to our solar panels. We would want to do that. From what I saw at the Iowa State University, they made some improvements to the panels, them to run at really hot temperatures. We might want to look at them and take inspiration from them. For vibration, it would obviously, our CubeSat would shake as it was getting launched into space, and we wouldn't want them to break the solar panels. So on Earth, it wouldn't be too hard to test like vibration. You could see like, you basically just shake them a lot and see how they handle. But yeah, if possible, it'd be cool to work with companies to like see if we'd get our CubeSat tested. And we want to, if we can't like, if the solar panels are really like shatter easily or get damaged easily, we'd want to find some way to pad them from that. And inevitably in our CubeSat research and design, there's some things we still don't know. And if we ever find anything else we don't know, then we want to find some way to solve that.
Mikey, I think you were the one that worked most on the manufacturing side of things. So do you want to maybe cover this part?
Yeah, sure. So with the manufacturing of perovskite cells, there are a handful of ways which they can be done, but the most cost efficient is spin coating. The spinning process induces evaporation and convective self-assembly processes, which helps to remove impurities from the crystals. It's ineffective for very large cells, which the research deems as 800 centimeters squared. But for the scale that we're working on, which would just be a few square centimeters, it's perfect. And there's 2 phases of 1,000, 5,000 RPM for 10 and 30 seconds each. And then after you spin coat the material, you then bake it to make it more rigid, and then you're good to go. Go to the next. And here we cover a few more methods that kind of will make it clear why we're choosing spin coating. The other most common one is drop casting. And it's essentially exactly the same, except minus the spinning portion of the spin coating. And the biggest issue with it is that the thickness of the layers is very inconsistent, and altering thickness leads to impurities in the crystal structure, which leads to very diminished efficiency of the panels. The next most common method is roll-to-roll printing, where you have the sheet of material that you want to lay the cell onto, and then as it rolls down with essentially an assembly line, material is deposited on like a printer. And again, that's really, really good for massive, large-scale ones. It's very consistent in thickness and the lack of impurities. But on the scale that we're working with, it's just not doable with the amount of machinery that's needed. And again, it's designed for very large scale cells. And then, there was one more slide, but this is just another 2 methods. So spray coating is another one where it is the same method again as the spin coating. It's actually designed to be a large scale variant to spin coating, because again, spin coating does not work. It does not stay consistently thick at large scales. So they came up with spray coating, but again, at the scale that we're working with, the very small scale, it's just not doable. And then the last one was blade coating, which is maybe the best alternative to spin coating. The only issue is it takes a very, very long time for this method to actually work. Whereas with the spin coating, you can have it done in minutes. The blade coating, you do it over the course of a full day or even several days. And then if you mess up, then you have to redo the entire process. And then on the next slide, we actually have a video of spin coating in action. And this is an actual perovskite cell he's making here too.
Do we have access to this type of equipment, or would we just need to arrange for that?
It is likely that they have it in the chemistry department. I've been talking to people who work in the chemistry department, and I'm kind of essentially just waiting back on answers right now. But from what I've heard, they should have this sort of equipment, because spin coating isn't like special to perovskite cells. Like this is done for other stuff too. But if they don't have the material, then we'll the equipment, we'll either have to build our own version of it or just buy it. But yeah.
John, do you want to talk about Oxford PV real quick and what you and I are trying to do?
Oh yeah. So one of the articles that we found recently talked about a photovoltaic company called Oxford PV, and they're working on making perovskite solar cells. Like I think they're working on them for Earth specifically too. And so that's a company that John McClure and us are going to try to reach out to and see if they possibly want us to test their materials for them. Because one really good partnership that we could have is if we test their materials, they provide us the solar cells for free, and then both of us win in that situation.
Awesome. That's definitely ideal, I'd say.
Yeah, and that way we wouldn't have to worry about the manufacturing as much because they would have professional equipment to make it, and they'd have the experience of manufacturing as well.
Definitely. If that always falls through, there's a website called Solaronics where they provide a lot of materials for perovskite research specifically. So you can buy kits or completed cells from them for very, very high prices, and they're very small. But if all else fails, we don't want to make it ourselves, there's this website too.
Oh yeah, definitely.
Everyone should take a look at oxfordpv.com at some point. They do a great job as to the technology and what they're trying to achieve. I've left a message on Thursday with the CEO and founder of the company. They're working remote because of COVID, so it might take a little bit longer. And then, of course, they're located in the UK, so they would. It takes a little bit longer to get through to them, but one way or another, we will have success with them.
Awesome. Great to hear.
Yeah. They're definitely a great resource. I think this was a slide that I made actually, so I can cover this part. But the arrangement, where'd that go? The arrangement that we're aiming for is a kind of half and half array. So because we're testing the efficiency of perovskites compared to normal solar cells, what we want to do is have an easy control. And the way to do that is to make an array that's half made out of perovskites and half made out of silicon cells. Also, another advantage of the half and half array is that if the perovskites turn out not to work, then our secondary mission of telemetry between the CubeSats can still be possible because we'll have the power from the backup silicon cells. Also, another thing that we're exploring with our array is tracking the sun. We haven't really looked too much into that yet, but if we can kind of orient our CubeSat toward the sun, that will even further increase the efficiency. And finally, going back a little bit to the manufacturing part of it, a solution that to the short lifetime of perovskites is encapsulating them. So basically you cover them in a sort of clear resin, and then it enhances their lifetime because they're not as exposed to things like oxygen and moisture. So currently we have two possibilities for how our CanSats, or how our, that says CanSat, it should say CubeSat, for how our solar cells will be arranged. The first is to have them deployable. So that would mean that they're inside the CubeSat and then they get extended. The advantage of that is that they're better protected during the launch, but the disadvantage is that they take a lot more space in the CubeSat. And another possibility is that they're stored on the outside of the CubeSat, which means that they take less space, but they're less protected during the launch.
Okay, so I can talk about this. So we're also partnering with like two different universities, North Carolina and Florida. And they're building their CubeSats, and we also have a goal of communication between them. So we're trying to demonstrate like radio frequency communication between three different satellites in orbit. We'll be using radio frequency bands just like normal CubeSats do in orbit. We'll be trying to communicate both between the CubeSat and the ground, and then the CubeSat and the two other CubeSats in orbit. We'll use a main bus unit to do that, and an on-flight computer. We'll be operating within like the 395 to 400 megahertz range. And we're thinking about using an ARM Cortex, a microcontroller unit to do that as the transceiver.
A couple points. Can we go back to telemetry? Since we're coordinating with the other teams relative to the three, there is going to be the same board, same communications board will be used from the same manufacturer to eliminate risk. We have a board coming soon, Kevin tells me, and so we need to get some more information on that. The other is one of the things that we should take into account when you do the research is Atlas Space Operations has volunteered to help from that regards. They make a living out of a new virtual way of managing communication between satellites and ground. So again, that would be a good learning, and maybe they have some ideas. And then also, we need to make sure that the communications all syncs up with North Carolina and Florida. So we have to really get the requirements down for that and then coordinate that as well. And use, all of us will be using GlobalStar. They are right now probably, besides Intelsat, commercially the only game in town. So again, think through how that will work into your telemetry. Does that make sense?
Yep. Absolutely.
Yeah, so just a little bit about our organization, how we will function, and how we will look for outside support. So just a little bit of detail for those who haven't heard it yet. The Big Red CubeSat team is the team composed of middle schoolers and high schoolers across the state of Nebraska, and the AXP team from the University of Nebraska-Lincoln is working with them from a mentor side of things, and also being team members with them in order to build this CubeSat. But we also have a support system through the Florida team and the North Carolina team. So in the Florida team, there's a school down in Florida called the Wise School with Kevin Simmons, who's been our main contact down there. And they have already launched one CubeSat, which I think launched in 2018. And they're working on developing another CubeSat, and we're working with them right now to write this proposal. And additionally, we're working with North Carolina, who has never launched a CubeSat before, but really working together, the three of them, in order to really create a support system that we can rely on together. And part of that is, especially with the CubeSat launch initiative, one of the big things that they're pushing is to try and get the CubeSat from every state, right? So the North Carolina and Nebraska, we haven't launched a CubeSat, so we're going to, by working together, we're going to be knocking 2 states off of that list. I believe from 9 down to 7 if the 2 of us get selected. And additionally, we don't just have support through other, teams working on CubeSats, but also through our professional mentors. So there's all of you on the call right now, as well as we have professional mentors at Ensign Bickford Aerospace and Defense that we have weekly, or no, not weekly, bi-weekly meetings with, and depending on how things go, we might have that be a more regular thing for design reviews and any help that we need along this process. And just like we were saying with the telemetry, right now we kind of have, or not kind of have, we're in the process of getting our membership to a kind of a committee between the 3 teams to work specifically on communications. So that's something that we're working on right now, and we'll continue to develop as time goes on. And right now we have ordered, I believe, some preliminary devices for testing that communication, as well as the Florida and the North Carolina teams have gotten started on that as well. Yeah, we can probably move on to the next slide now. So for the schedule, we still are figuring out the exact deadlines and everything. Right now we are planning on using a Microsoft project to kind of plan everything out. But we have our PDR today, October 24th. We plan on going through 2 different really design stages, both the engineering model and the flight model. And we have preliminary prices for those, but we'll talk a little bit more about that in a second. But we kind of what we're aiming for is to launch in the spring of 2022. But really how that will work, we don't know yet. So it could be anywhere between 2022 and maybe, later 2023. But really kind of the process that we're going to try and orient our, design through is where we're going to go through our initial, paper and pencil design, kind of talk about the concepts, and then move on to theorizing what's actually going to happen with our design through a lot of simulation, through circuit simulators, through different emulators to test our software as well as using SolidWorks to kind of run some preliminary finite element analysis and just different simulations, and then actually going through that building process to actually test that our simulations held true, and then go back to the design process again and really repeat that, hopefully several times for each component, as well as when we integrate things together and go through that process. But I guess a little bit more on the budget. So we have done some preliminary price points right now, but because we are working with the Florida team and the North Carolina team and want to use a lot of that same hardware, we're a little bit limited on maybe what we can use, but we have that support system, which is really the benefit for this this partnership. But we are looking at probably about $75,000 for the engineering unit and the flight unit. So in total, probably about $150,000 to develop this. And we have several people working right now to kind of start on that fundraising process. And really, we're going to kick things off once we submit our proposal and hit the ground running. But I believe that's all we have today. Do we have any questions that we can answer before we kind of talk about, a little bit more about how we can improve this PDR for next week?
Tegan, did you want to say something?
No, I have to go. So that's
okay.
Well, thanks for joining us, Tegan.
In regards to Oxford PV, if I could ask everyone, and John, if you wouldn't mind coordinating, a list of questions that you want to ask them. What I'd like to do is submit those early, sometime mid next week to them to show them that we're being thoughtful about what we're doing here. And that will get them hopefully more interested in working with us, because they tout themselves as the premier manufacturer and developer of this type of panel on that. And so we'll go from there.
Yeah, that sounds good. I'll do that.
And John, you should you guys did a really good job on your write-up and putting the payload in there. If the rest of the team hasn't seen that, they should, because it's really good.
Thank you.
Joel, did you want to talk about next week?
Well, let's see if Matt, Justin, or Taylor have any comments or suggestions.
Okay.
I was thinking, really overall, this is really well put together, and you cover like the main buckets I think that the board will be looking for, right? And I think your approach to everything looks really wonderful. The one comment that I had in the beginning, at the very beginning of the presentation, it wasn't entirely clear to me whether you were trying to develop these solar cells for space use or earth use. And so I think your aim, right, is to test these solar cells and how they might work in space. And so maybe focusing that goal to help frame the rest of the presentation at the very beginning might be helpful.
Yeah, absolutely. I think that's accurate.
Taylor, have you, in your PDRs has there been more graphics? Do you guys use charts and arts and things like that? And how would you suggest just the presentation overall of the material? Any thoughts? All three of you?
I would maybe want to start out asking what stage the project is currently at. Is this pre-proposal work?
Yes, it is.
Okay. So this is more of a mission concept review.
Mm-hmm.
As far as I can tell. So maybe a PDR is not the right name here.
It actually is supposed to be a PDR, Matt. This is the initial design review is actually supposed to be reflective of our proposal. And the proposal will get submitted to NASA. And of course, what they want to know is, will it work? What's the benefit, especially since this is an educational program? What is the likelihood of success? Because they're going to spend a ton of money putting it in space. And our portion of that is maybe 150, 200,000. Three, what is the likelihood of there being some benefit? So they want to see some more detail. They want to see some more engineering. They want to see, in effect, they're ultimately deciding is if we spend this money, are we going to get a return on what our objective is? So this is supposed to be a real PDR. So again, your thoughts, if we're not hitting that mark, what are we missing? Is it more detail? Is it, arts and charts? What are your thoughts?
Okay. Well, in general, from a PDR, I would expect there to be systems and subsystems described of what's being built. Something with, say, mechanical systems, the structures, the mechanisms, descriptions of those, and anticipated approaches to that. Then for electrical systems, description of the systems that you'll be using. Do you have a main controller? What sensors will you have? Those sorts of things. Then additionally for software aspects of that, what controls you'll be needing. And those just not being described in great detail, but the approach that you would be using is what I would expect from a preliminary design review. Because I think those things really get to what the design is. It's hard to judge whether something will be successful when you don't see what the actual device or components will be. And that's kind of why I was seeing this more like, it reads more like a mission concept. So I think those are important things to answer for what is being asked of you from this program. But definitely would suggest if it's a preliminary design review and they want more design with that mission concept of how it's going to be accomplished. Definitely would like to see more of the how in that regard.
Good input. Great input. Great input. Would any of the three of you have something that you have done that folks could take a look at and get a better idea of what the deliverable is.
Okay. Potentially.
Yeah. We actually have the RockSet X. We have the RockSet X PDR as well as the CODR in a drive, and we had that looked over a little bit, but definitely something that we want to continue to look at as we work on this.
Yeah, it's interesting that they're asking for PDR level stuff before even awarding you anything.
Yeah. I actually like to echo that too. So
that's
I'm
weird.
a little surprised.
That if you guys are interested, on the 24th, there are going to be, what was it, John and Joel? Weiss is doing, Florida's doing 4, North Carolina's doing 1, and Nebraska is doing 1. Is that right?
That sounds right.
Yeah.
So if you want to watch all 6 or even one of the 6, we'll get you access so you can get a sense of. But the other 2 teams will be at Kennedy Space Center with NASA engineers as well, reviewing this. And again, the whole concept is, what are we missing before we actually do our proposal, so that we have the best proposal out there, so we're selected ideally first, but as long as we're one of the ones selected, we're okay.
Yeah, I think definitely a notional approach. It doesn't have to be the approach that you ultimately end up with, but just that you show that you've thought through the things that are required to build a CubeSat, to outfit it with electronics and have the proper structure, and then be able to control it. Some things that were mentioned, such as solar tracking and pointing, those active systems require much more thought and reliability if you actually want them to operate. And then certain things like communication between different CubeSats, maybe that requires pointing, because a lot of the gain on antennas that you use is helped by having a large structure. But if you can't have a directional antenna, then it's just, antennas get hard if you have low power and not a lot of space. So it could require certain things like pointing that become more difficult, and would be good to have a initial game plan.
I agree with Matt. I think that's really valuable feedback. And I guess I also was thinking it was more of a mission design type approach. So I think if you guys are really aiming to achieve PDR, that all of those things would be really pertinent.
Certainly.
I think also, adding to some of that, there was a couple slides and some discussion in there where you were still asking questions on what exactly you wanted to explore, and what the questions you wanted to answer. And I really think those kinds of things need to be known. What exactly do you want in this test? What are you concretely are you planning on doing? You had a lot of really good background information for different aspects, but I didn't see a lot of time spent on exactly, this is the problem we want to do. These are the objectives we're going to meet, and then here's the steps we're going to take to meet those. I think those things you need to have in here as well.
Certainly.
Also, could we add slide numbers to this?
Yeah.
That'd be very helpful, especially
Yeah.
for anyone reviewing it, so you can reference.
Yeah, good point.
Mm-hmm.
What do you think? What do the 3 of you think about the overall concept and the probability of, if we do everything right, as the team does everything right, what do you think about the concept overall?
I think it's an interesting problem. I think I think it's a cool project that you guys could gain a lot of knowledge on. You know, a lot of these projects, one of the big pieces is getting students knowledge and building their expertise on these topics and getting experience. So I think this is really good for doing that. I think I think for understanding what the you mentioned earlier, the feedback, what NASA would gain exactly from this project, that wasn't entirely clear to me on some of it. I am also not clear on what is it about the launch that is unique to testing these solar cells. What does that buy you that you can't do in a ground test? That wasn't clearly made, because if you can do it as a ground test, that's a lot cheaper, and you don't need to do it in an orbit. So that's something, I think, a good question that would be, you know, something for you guys to think about, to go through. You talked about, I think I heard a question on probability of success. I think to answer some of that stuff, you guys need to think about what the risks are. Understand, at least have a thought process and gone through the exercise of, okay, what happens if deploying the solar cells fail? Or, you know, how do we test to make sure that we're confident that it's going to work? Or is there some other mitigation we can go through for something like that? Or if a microcontroller fails, or your power doesn't work how you think, or telemetry, or you just go through, like, what are the tests we need to do to make sure that we're confident in it, or redundancies, how you design it. Another thing, maybe going into too much detail here on the risks, I think I heard you guys mention that you're testing these solar cells, but they're also supplying your power needed to run the CubeSat. I think that might be a risk here, is if there's a probability that these things won't work as well, and that's the whole goal of you testing this in space, is that they might not work in space. That sounds like a risk to me. If they don't end up working, then you can't use the CubeSat.
Yeah, they did mention that they would have a more standard flight-proven hardware as half the design. So I thought that was a good idea.
Oh, that is good. Yeah, I missed that. Okay, thanks. Thank you, Matt.
And just to add what Justin's saying, some good format for that might be a risk matrix. And a risk matrix is essentially the likelihood of the problem versus the severity of the problem, and it's usually color mapped and very kind of obvious what if you have a low chance thing that could happen, but then it sinks your mission. That is immediately obvious. Or if you have a like a low severity thing, but there's a high chance it could happen, like as Justin mentioned, your solar cells are not performing as needed. That could certainly happen, and then might not sink your mission, and it might just be something that you're tracking. But just showing that you're tracking these risks and understand their severity and their likelihood is also helpful.
Yeah, definitely.
And it's not a bad thing to present, right? It's not a bad thing to show like a risk matrix. Like Matt said, that's something that everybody uses. And if you have high risks, right? If you have the ones that are, yep, this is very likely, and yep, this has a high severity or consequence, it's okay to show that. But then, you know, it just shows that you're aware of what challenges are in front of you. And it's a really good engineering practice. NASA likes to call it risk-based management. And so if you can go in saying, we know how we're going to manage our design, and we know what challenges are in front of us, that's a really beneficial thing.
Right. The risks aren't bad. It's knowing how you are going to try and mitigate them.
Exactly. That's where the engineering happens.
All great feedback, folks. All great feedback.
Absolutely.
I think given the time that you folks, the team, have worked on this and where you've gotten is phenomenal. You at least have direction. You at least have what you want to do, and it's worthwhile. And Joel and John, you guys are doing a great job at leading them through. So we just need to get that structure so that we have a successful proposal. That way I can go pick people's pockets.
So to give Matt and Justin and Taylor a little bit of context, we started this mid-August, just actually even having a team. And then from there, I think early September, identifying potential projects we might do. And then as Taylor knows, we chose our project last week, which one of 2 options. So I think the students have really done a good job pulling this together. The PDR date of next Saturday was set for us based on when Florida and North Carolina could be at Kennedy Space Center. So I think we would very much prefer not to quite have it this accelerated, but it was defined for us. So I think we're going to have to prioritize on all the things that we should have, get what we can get done for Saturday. I think the students did a great job, and I know we need to be a little bit smoother as far as knowing who's going to do what, which slides, so we don't have that question. The goal that we have is the request for proposal actually came out, I think, 2 weeks ago, and it's due December 16th. And so definitively, I think we should try and get as much of what you guys have brought up for the PDR, but then for our actual proposal. And so we may, if you're willing, we may be tapping you again to help make sure that if we don't get it all for the PDR, that we have a really sharp proposal, because we have a little bit more time to get that piece done.
Right. And I think going into the weekend, given the things that Matt has brought up and Taylor, as well as Justin, if we just even show a slide that says risk matrix goes here, and so folks that are in Florida at the Kennedy Space Center knows that we know we have to do it. So it's not something we've forgotten about. It's something that we have to work on. And so I think that goes through as to, at least they would understand that we understand what the deliverable is. And Kara, I think it's a great idea to beg them to come back and do a real PDR back in November before we submit the proposal. I think that would be outstanding. It might help, John and Joel, if you send them a copy of the RFQ, or sorry, RFP, and also the copy of the proposal that Kevin sent to you, the one that actually he feels is the right winner. At least they understand what we're trying to emulate at this point.
Yeah.
Certainly, yeah.
One other thing I would suggest adding to your front matter here with the mission statement and what you hope to get out of this is, it's called technology readiness level. And it's something that NASA often points to, that scale of how far have you gone from initial concept being developed to, is this flight ready? And then is this just something that we use all the time? And there's like nine levels. Sometimes there's more, depending on who you ask. I think the NASA one is 9 levels. But you know, when we submit proposals, a lot of times in the research directorate, they want us to enumerate what is the current state of the art, then what is our current technology readiness level for what we're working with, how they compare apples to apples, and then what is the technology readiness level that we want to achieve through this work. We're not going to jump all the way from TRL 1 to 9 in one project. Is usually, if you can get one technology readiness level step, say something like you've worked with it in a lab and you've shown already that it's producing power, but now you want to fly it, that one step is extremely beneficial. Usually that's the hardest step, getting it flown. A lot of current work at NASA trying to make sure there's enough opportunities to have the jump from a lab environment to a relevant environment or operational environment. And I think that's the biggest thing that you guys are offering here is demonstration in a relevant environment. And that's, you know, one thing you can't 100% do on the ground. You can get very, very close with conditions on certain things, but if it's affected by radiation or gravity or other noise and heat and cooling cycles in orbit, that's not 100% something you can demonstrate on the ground.
Yeah, I think that makes a lot of sense. That's also a really good reason we can use for gaining in launch. So thank you.
Certainly, yeah. Thank you.
Do want to comment that you guys have, it's obvious you guys have done a lot of work in the background research, and that's something we've talked to you guys, the team, the XP teams in the past, is to make sure you get research the background, see what's being done out there previously before you start designing and making something. So it's obvious you guys have put a lot of work in that one, and that's not something that's really quick and fast to do either. That it takes a lot of time. So you guys have done a good job getting a lot of the groundwork information that you need.
Thank you.
Well, the three of you just remember where you came from, that this is home, and someday this is an initial project to hopefully start a new economy in Nebraska, and that will attract you guys to come home and start up a company. When you do that, I'll be the first stockholder.
Hey, we want to make our own NASA center in Nebraska. That'd be great.
Well, let's do it. Let's do it.
You just need to convince the congressman.
That's easy. I'll run.
If you guys have any other comments, whether now or later, we actually shared kind of an edited version of your comments for the USIP team with the team, because I felt like those, I told you I use them for my class. So, but I think they're really helpful. So if there are any other bits of input that you want to give us to help us polish up, you know, our PDR may not be, some of the system development stuff may not be as far along as we would like, but I think the more professionally we present, that also reassures people that it will get there. So we would appreciate that kind of feedback. I mean, I'm so impressed with the team members and what they can do and what they've done. But even for myself, I can use feedback on how I can do things better.
I would love to see Nebraska launch some CubeSats. We got to get that going. So I'm glad you guys are working on it. This is fantastic.
I have probably a stupid question here for you guys. I'm not entirely clear, although I think I know the answer here. Oh, as we've talked about it back and forth, I've kind of flipped back and forth thinking on what this means. You guys aren't planning to launch from Nebraska, correct? This is launching. Yeah. Okay. That's sometimes how you guys have phrased it. I was sitting here wondering, wait, is that what they're trying to do here? Okay. So that's what I figured. Okay.
That would be extremely awesome if we could, but I think that's going to be more down the line.
Yeah, I figured as much. I was even really surprised if that was the case. So
yeah,
just drop the first stage on Iowa. It'll
there
be great.
You go. No big deal. I like cornfields. This is fine.
Right.
The Y school was made up of 6th and 7th graders, and they launched on the Falcon 9 out of Vandenberg.
That's
So
fantastic.
our goal is we don't know if this round is going to be an actual orbit from the rocket, or we're going to get kicked out of the ISS on the Japanese porch. But one of the two.
Mm-hmm.
Okay. So do you know if it's one of those two options? Do you have a rough idea of how long you would be in orbit for?
Right now, WISE is still communicating telemetry, and they launched in December 2018.
Oh man.
Okay.
So that give you an idea. And if this, and if when we're successful, we could go for a couple of years given this testing.
Yeah.
So it would be great to continue to have that ground communication.
In that case, you guys could really study the degradation of the cells.
Yeah.
And that's extremely important to look at, especially if you want to send a deep space mission. You know, are your cells going to give out on you after a certain time? And you know, usually missions are designed with solar cells that they look at where, you know, when they first launch, they've got high efficiency, they're running great, all your cells are functioning, maybe a few didn't survive launch, but then as time goes on, it starts to dip, and then you're losing power throughout the mission, and at some point you just don't have enough power to run your mission, and that's where your lifetime ends.
Yeah, that's one of the areas we hope perovskites can really help with, especially because the one that lifetime is something that so far on perovskites has been very much tested. Like the longest so far has been 450 days without a drop in efficiency, but that's of course like in Earth conditions, and that's not with radiation. So one of the biggest reasons we picked solar panels is because we were looking at the ways that CubeSats fail when they're in orbit. And the big one, like you said, was solar panels and power systems.
Mm-hmm.
That's a really good piece of motivation you should put in the presentation.
Okay.
Oh yeah.
Yeah. Definitely.
Put that in front.
Yeah. Yeah. I think it's really good to have, you know, the talk about general idea of what we have. Here's our motivation, and then here's our goals and objectives for the work, and then you kind of start going in from there to hit with those big three.
Yeah. Okay.
In terms
go ahead, Taylor.
I guess just in terms of chartsmanship and sort of piggybacking on that, Justin made a good point that it's clear that you guys have done a lot of research, but in your charts, you sort of say like, this person did research, and then there was like source with hyperlink. Right, being on the receiving end of the presentation, I don't really get to use that information. So it's good to have your sources cited, right? And that's fine. But pull out
That's so interesting that you say that, John.
You're right, Amanda. You're right.
Last night, John and I argued about it for probably 15 minutes, and whether or not we should have cited sources on our slides. And so I'm really happy to hear you say that. It's the bottom line.
I mean, it's good to say that, you know, this isn't our own data, but I think the way that you did it, I mean, to be honest, was a little bit clumsy, and I didn't understand what information you pulled from those sources. And so I would encourage you to revisit that before you present next week.
Yeah.
We're trying to get parenthetical citations in with the information, kind of like you said, just to make it clear like where we were getting our stuff. But unfortunately, when I went to make the citations at the end of the presentation, I wasn't sure what was used where. So yeah, it is something that we will have for the PDR on the 24th.
I mean, you can put footnotes on slides. That's fine.
I'd recommend footnotes.
Yeah.
Have a numbered footnote or asterisk footnote to where it's relevant.
You can also, I think in the reference or review tabs, it's reference. There's a citation bibliography options, and you can do links in there if you wanted to have them numbered. And then you could populate a reference slide at the end. And let's say your reference 1 was on slide 1 and reference 2 was on slide 2, and then you switch those 2 slides around, you can update the link and it will automatically populate the order there to renumber them if you want to keep it in number of when they appear. So that's a way to automate it. It can be clumsy sometimes, but if I would spend maybe a couple minutes trying to figure that out. If you can't, then just make a note on your own, and then you can put it in there as is.
It's kind of like making captions in Word.
Yep.
Justin, does that automatically update, or do you have to command an update? Because I know in Word you have to command it.
Yeah, you have to tell it. Yeah, if you just move it, it'll say the same. You have to tell it to update.
Like usually in Word, I do Control A to select everything and hit F9 to update all fields.
Yeah.
So.
Yeah, another option is just do it all in Word, put it in there, and then you can just copy paste it over at the end. Or you can put notes for yourself at the there's a little note at the bottom of your slide package. You can just add notes there as is. Usually people use them to read off of. You can put it that way.
Good feedback. Gavin, what did you learn today?
I guess I learned that we still have a lot to do, and we should consider more of the mechanical side of things.
Oh, yeah, and in that area, you don't have to have like a full model or anything of your CubeSat for this. I would say, I think just notional locations of what goes in the box is what you would want. Say and then you're going to need some sort of deployment mechanism or stabilizing mechanism, and say it's going to go in there and it's probably going to take about this much space, and that's as far as we've thought about it. But we know we need it, and we're going to figure it out.
You guys had a chart that showed like system level interfaces when you were talking about your like PWBs that you're going to use for communications or something towards the end of the slide deck.
Yeah, let me see if I can find that.
That sort of indicated, I was looking at that and I was like, oh, this is the part where they're going to start to talk about like what they're going to use for all of this. But then this one, that chart up in this right-hand corner, is that actually what you guys are using? Or is this just like a notional example?
Yeah, so that's specifically for the bus unit that a lot of, so the North Carolina team and the Florida team have been like kind of researching. This is, I believe, the bus that the Florida team used for their CubeSat that they already launched, and the one that they're working on developing right now. And so it's something that we're like looking into, but we might want to like design a little bit more of that ourselves, because it's pretty much like a put together CubeSat, and then we just put our payload in there in that case.
Yeah,
if that's the case, then I would say, we're going to use this standard structure computer system, and we're going to put on our experiment for it with our specific things. I mean, satellite companies, they don't go and recreate a bus every time. So it's just a platform for you to do what you need, but definitely show what platform you're going to be using.
There's a word we hear all the time. It's heritage.
That's right.
All the time. If it's worked in the past multiple times, there's no reason to change it. So
lowers that risk.
Yep. Actually, that's a really good point. When you talk about your risks and stuff, if you have these boards and they've been used by multiple student groups or other companies or what have you in the past with no problems, that's really good reason to use it.
Yes, our design will rely heavily on flight-proven hardware with heritage.
And it's less for you to figure out too. You don't have to go and redesign something. We talked a little bit on the slides a little bit, the slidemanship. A couple points I have is for that is be careful of putting large blocks of text in your slide packages. Really, slides need to be, when you're presenting, is short bullets, and it's really just reminders for you to talk to. Because if you have big paragraphs of text, as a viewer, I essentially have two choices: listen to you or read the text. I can't do both. Be careful of that. We mentioned the URL links. There was also another slide, I think, on the budgets that was full of URL links. For us as reviewers or listening to this slide package, that really isn't very helpful. I think the main thing that you kind of talk to the point, which is good, just put it in the slides, is for budget, what is the amount you're looking to get or spend, and where's that money going? Now, those are the really key things. That's the stuff that you want to hit home with in these kinds of presentations, not necessarily here's our vendors we're looking at.
Yeah. And where it's going could be just allocations, like you're going to put this much money towards electrical, mechanical, software, or launch.
Yeah.
To piggyback on Justin's point, I completely agree, right? You can either read things on slides or you can listen to the presenter talk about them, but that doesn't mean put pictures on just to put pictures on to take text off.
Yeah, that's a good point.
Right. It has to be relevant or, aid to what you're talking about, right? You can't just be like, oh, launch, like here's a rocket, right? That's not necessary. It doesn't always help your cause. It's okay to have stark screens in front of you when you have important points to get across.
Yeah, you want to focus on what the point of the presentation is. As much as I like pictures of rockets.
I mean, same, but yeah.
Going through these exercises of presenting material to folks is an exercise in trying to be concise in what you're presenting. That's a skill that it takes a long time to learn and essentially a lifetime to refine. I still go to presentations with people that have been in industry for decades, and they'll throw whole paragraphs of text. It just happens. So, but if you can, get in the practice of doing that, especially early in your career, you're going to be that much better on later on, and you'll be very effective in communicating your points to people. And that being effective at that is going to make it really easy to say, here's my cool idea. You should fund it, give you money, and then go run with it.
And I like to say that half of engineering itself is communication. How do you get anything done that's large scale or difficult? Is you need people to understand what you're saying and what you want to do. So it's why drawings are important. It's why concise PowerPoint slides are important.
I tell startup companies that people bet on people. They don't bet on PowerPoint. So you got to be able to make sure that you're confident and that you are passionate, because that's what people ultimately are going to bet on. And then, are you intelligent? That really comes third.
Definitely.
Also, doing dry runs like this, right, and flipping through, that's invaluable in terms of how you come across and everything else. You're doing the right types of things.
And we've all been in doing this process of going through slides and having people go through them. For conferences that I go to, my branch, before I go to that conference, any branch member, we all sit down, or a good chunk of us sit down and go through the slides, and we will go through sometimes line by line, which is pretty torturous, but it still helps, and you get a really good product in the end.
Oh yes, we do that in my branch too, slide by slide, line by line. So why did you capitalize that word? Well, I'm sorry.
Yeah. Yep, it's a normal thing.
Yep.
Chart run throughs and getting torn apart on why you did stuff is a part of it. It's not bad, just makes everything better.
Yeah. I mean, I can definitely tell we've gotten so much, like our presentation next week, this week is going to be just worlds different thanks to your feedback.
Mm-hmm.
Oh yeah, keep practicing. It gets better every time. So, and you really hone in on your message and what's important every time you present, because it's hard the first few times just knowing what you want your audience to focus on.
Also, something that might be useful at the end, this may be out of scope, but including a list of your team members and their like roles, right? Like you guys have a super intermixed team, right? You have high school students contributing, you have college students contributing, and saying, look at how all of us merge this information together. And then when you present as like a cohesive unit, and you know, and just sort of giving the review team a highlight of that at the very end, even though it's not necessarily like, I don't know, not what you would think of like as engineering pertinent, but it shows that you're already establishing like communication lines and roles and responsibilities and stuff. And that could really help your case and say, you know, look, we're not all grad students here doing this. Yeah, like this isn't, yeah. I think that would help aid your presentation validity at the very end.
And yeah, it's just like Taylor said and what John said before, companies people bet on people. So show who you are. And I know you guys had some organizational charts near the end, but I would definitely, I think that'd be good to bring closer to the front. Say, this is who's working on it. We're cohesive and we're moving forward.
Yeah, that is a great comment. I think we need to, at this point at least, list the names and the grades and maybe their schools just to show, you know, how they've had to work together. And then actually, Taylor, with your bringing it up, it reminds me of USIP, and we've kind of been a student team, but I think we probably need to start thinking about, okay, who's going to be our project manager, who's our electrical lead, our mechanical lead, our software lead, and actually get a really well-defined organization chart, working with the students to figure out who can do what and who wants to do what, to make sure that we pull all the pieces together.
I think that'll be great. Yeah, roles and responsibilities, establishing those and having them very clear helps with communication.
Yeah, and so I don't know that we'll have it, but for this, but I think it will really, we need to have it for our proposal. And, you know, just like we did for the USIP proposal. So thank you. That's a good point. Great point. You guys are the best. Thank you for joining us.
Certainly.
Hey, Caleb, before you go, do you have just another 60 seconds?
Yeah, I can stay for a little while longer.
Okay, it's not much. I think before the students have to go, we should probably talk about Saturday, Karen?
Yeah, I think so too. Do you want to talk to them, or do you want
No,
me?
I can be the bad guy. I'm good at it. Ask my grandchildren. Unfortunately, the governor has put out another health directive. And so it limits significantly what we can do in a group. So we're going to have to postpone, for your health as well as others, the in-person meeting at the museum on Saturday. We're going to have to go to Plan B and do it virtually. But I promise you all that we will have a fun in-person meeting as soon as this COVID stuff sort of goes away. Please don't think that our ability to present and do a great job is really contingent upon you physically being there, because you guys are doing a great job virtually today. but we will party. I guarantee you guys a party. How's that?
No, we don't want to pick certain, if they limit how many people we can have sat at the museum, we don't want to have to pick who gets to be in person and who not, and how far do you have to stand apart to present and that type of thing. So it just seems it's easier. And probably your parents are like, okay, good, I don't have to drive, or at least I know, sooner rather than it being up in the air. Yeah, they're probably relieved. Okay, so if you can let them know that, and we really want to get to meet you in person, but we want to do it safely.
And we will try to send you guys out a package before Saturday. We'll try to logistically get that to you before Saturday. So look for something hopefully to come by Friday.
Certainly.
Any questions? Caleb, Dylan, Casey? Okay, yours.
I was just gonna ask one thing, like mostly for like the Big Red Sat team. So going forward for next Saturday, I think one of the biggest things we have to work on is just knowing like who's going to present which slides. So like I know last night we had a meeting and a lot of people were able to show up, but not everybody. So is there a time during the week that kind of everybody's available that we could all get together and kind of really hammer down on the slides one last time?
Instead of answering that right now, I'm going to post a survey in Slack so that we kind of have a written record of it.
That's a great idea.
So just keep that in mind.
Yeah.
The only other consideration that a lot of the students have after school activities. So if it could be done a little bit later, we might get more.
Mm-hmm.
So here's a really small thing, but something that might be nice is to look like a team. Maybe if everybody wears either a white or a red or a black shirt. And so it will just look really sharp and crisp when you're on the video, because when you're talking, we'll want you on the video. Then we will look cohesive in how we're dressed. Does that sound good?
Yeah.
Would you prefer if someone's got a Nebraska shirt, they wear that?
Yeah, Nebraska shirt's fine, or else wearing white, red, or black, just so we look like a Nebraska team. Thanks, Caleb. Any other thoughts or comments on how we pull this off professionally?
Smile.
Any specific comments on since we are doing this remotely, about how to coordinate, presentations together over Zoom?
Relative to the KSC?
Yeah, and since we're not going to be in person at the SAC Museum.
Yeah, I sent a note to Kevin last night, and he is going to set up Zoom links, and we'll just have to do the best we can. You guys are going to have to be a little bit, either you're going to have to be the PowerPoint pusher or slide advancer, or be able to share your screen. Sharing your screen is very cumbersome, as you all know. And the last thing we want is to take time away and have technical glitches so everybody forgets about what we're talking about. The other thing too is we're going last. That is never the best position to be in, because we are standing in the way of someone eating, playing, or sleeping. So that's something to consider. So I'm not suggesting that anybody sings, but you just need to be really passionate about the way you present, just so people are interested. And to remember you.
I was a part of this big virtual event a couple weeks ago, and we sort of had a set list that they sent out beforehand, and they sort of laid out a timeline, and they said, this is how much time we have. And sort of the people who were presenting and speaking new, right? And it wasn't a question. So even though virtually there's always going to be a little bit of an awkward handoff, right? And practicing like this, you get through that. But if you guys can come up with like, okay, John's up first, then Caleb, then whatever, and like 20 minutes in, like remind yourself, like, okay, people have been listening, laugh or something, right? Like you can orchestrate it like that and make it very like theatrical almost, and that will just kind of help set the expectation for everybody. And that's been successful in at least big conference like virtual worlds.
And it's definitely good to know who's speaking before you and after you. So the handoff is more of a person-to-person thing, not just like, oh, okay, the next person's going to speak. You say, all right, I'm going to hand this off to my colleague, and they will continue on this section. Something more fluid.
Yep.
Yeah, so this week we didn't know who was going to present for some of the slides. Last week, I felt like on the mushroom and or on the fungi and the solar panel, those presentations, that was really crisp. It was nicely done. It seemed like everybody knew which slide they were supposed to do. And so we just need to get back to that level now that we've settled on one. One other thing, real quickly, we said that you might get packages in the mail, and we can only send you a package in the mail if we have your address. So can Joel or John or MJ, do you want to collect those?
Yeah.
Yeah, we can get that taken care of.
Okay, so I don't know if we need to type in the chat like an email address that everybody should send their address to.
We'll send out a form in Slack so we can get all that.
Do it through Slack. Okay, so and let's if everybody can try and get their address to us, by Sunday, so that if we're going to mail something, that hopefully we can get it in the mail quickly, so you actually have it by Saturday. Okay.
Also, if the guests could send some information to us as well, we'll get you maybe a copy so you guys have a sense of what's going on.
And it was mentioned we would love to have you guys participate in the PDR if you're available. And like we mentioned, we're going to be last. They're anticipating that it's going to go, I think, from 9 a.m. to 3 p.m. I'm guessing therefore we won't be on before noon. I don't have the exact schedule. So
we're going to be last. And if you figure on, it will start on Eastern time, 10 to 4, and an hour break, and then a small break between each team. I'm guessing that we'll start probably around 2:33 Eastern time, so 1:32. But we should sit through all of them because all of them are going to be learning for all of us. So it will be a long day, but it'll be a great day.
Yeah.
For learning.
Yeah, that makes a lot of sense. And definitely anytime I've gone to conferences, or even before that when I was participating in engineering design competitions, I learned so much just from seeing what everyone else came up with and talking with those teams. And unfortunately, I don't know how you'll talk with those teams, but just seeing what they did, it's extremely helpful because they all have different approaches and like things we never even thought of.
Yeah, so it'd be great if all the student team members were there for all of them, and then Justin, Matt, and Taylor, if you're available and can actually watch, see how our team does and give us feedback, that'd be great. Yeah, we suck you guys in. You agree to one comment, like, hey.
Yeah, you just have to do that with the program and to suck them into funding you all the way through a launch.
Yeah. And you guys were asking, so this is the CSLI, the CubeSat Student Learning
Launch initiative.
CubeSat, yeah.
Launch Initiative, right? CubeSat Student Launch Initiative.
It's not student, it's just CubeSat Launch Initiative.
Oh, is it? Okay.
Yeah.
And they, on that, we actually get to tell them about when we think we'll be ready. And then we have to tell them kind of what orbit we think we'll need. And then then they kind of decide from there. So there isn't a set rocket that we're going to go up on. So just, from your earlier questions, it will be responsive to what we think, when we think we're going to be ready and what we will need to do it.
So,
Now, don't you guys wish you were us now?
yeah.
I mean, I wish that we did anything aerospace related when I was in school as a middle schooler or high school student. We had to
Same.
make our own fun in college.
Same. Yeah, I've actually been very impressed, especially with UNL, since I've graduated, that the amount of involvement in these activities and student design projects seem to be significantly more so than when I was there. And I think that gives you guys really invaluable experience in applying the skills you're learning in classroom, which is really good. So you guys are gonna be much better engineers than I am coming out of these things.
That's right. Be better than us.
Yeah.
You guys can do it.
Do you think it would help them get a job after college, having this on the resume?
Easy.
Oh yeah.
Definitely.
Yeah. When I hire interns, I'm always looking, okay, have they actually built something? Have they applied their skills? And this is one way to show that you've actually built something. You've gone through the process and you've, put pen to paper, then taken that paper and put saws to metal.
And Earth to space. You
That's
can send
right.
that stuff to space. It's the coolest thing. And it's wildly useful. Same thing when I'm interviewing people, I'm like, okay, so you were a good student, fantastic. What did you actually do? So you guys are on a great path.
Yeah, application and just applying yourselves in this way, it's definitely makes you stand out more than just a GPA, in my opinion.
Yeah, it's funny. I usually tell my college students not to include anything pre-college, but what you guys are doing now, if you can say, I was doing this in 8th grade, that definitely goes on the resume.
Mm-hmm.
Very, very notable.
Yeah. And hopefully this leads to more and more projects that you guys can do later in high school and into college. Maybe you guys will be sending people on the moon.
And the AXP mentors, to be putting this on your resume, that you helped these kids achieve that and built, is, again, you guys are, just as long as you keep working so you support my Social Security, you guys are doing well.
Mentoring is critical in any organization, especially NASA. If you look at our demographics, we have what you call bimodal distribution of ages. So we have lots of really young people like Justin and I, and then we have lots of older people who came in with the shuttle program. And there was not major hiring in between, and in order for NASA to maintain its operational capabilities and its level of excellence, there has to be a constant transfer of knowledge from the older generation to the next generation. And it's a little complicated for us now as people are coming up on retirement age, the people whom we are learning from. So mentoring is extremely important.
I have a question about that. So applying for a place like NASA as one of the younger people and having something like mentoring middle schoolers and high schoolers on our resume, do you think the best way to phrase that as an asset to the company is like, hey, I've experienced mentoring people, so I would be so I know how to also be mentored, or like what's the best way to, because like I'm assuming as a young person coming in, you're not really doing much mentoring, right? You're more learning from the mentors.
Let me preface before the others speak. As a 66-year-old guy who has been in business for 40 plus years, the way you phrase that is simple. I provided leadership over a team that accomplished Y or X. That's the elevator pitch, because we need leaders in all facets of business, whether it's aerospace, automotive, energy, and that's what you guys are doing. And the team members, they're also being leaders in their own way. So I'm sorry I stole a little thunder, but Taylor, what are your thoughts?
I mean, yeah, leadership is important, but John, I think you're hitting on the right point, right? Is you've been a mentor, and it shows that one, you're generous with the knowledge that you obtain. Sometimes that can be detrimental in industry, right? People like to hold on to their knowledge. So you're the type of team player that people want, right? It shows that you know how to be a part of a team and to learn and to give information. And I think that that's wildly valuable. And to what Matt said, right, is like knowing how to be, I don't know, how to be a mentor and a mentee, right? There's two sides of that equation. And so when you've been a mentor, you know the types of questions you would want to be asked to gain information. So it just kind of shows that you've already got that skill set of, yeah, again, I think it's a lot of team building and team interaction. It shows a lot of that initiative and just self-awareness.
I learned my leadership skills under a guy by the name of Ross Perot, who is a founder of a company called EDS. And what he said was, great leaders know how to follow, which is, to Taylor's point, to be a team. Sometimes you have to give up something in order to gain something. And that's, and collaboration and listening skills is just phenomenal. And mentors need to listen. And that's also a great attribute to have in someone who is in your employee.
Yeah, and taking on with that, team leadership is just as important as team membership. And being a leader does help you learn how to be a team member. If you don't let your ego get in the way.
Yeah.
Certainly.
Okay, thank you.
Well, it does seem like a few people need to get off, and we are reaching kind of the end of our normal meeting time. Does anyone have any like last minute questions before we kind of pack up for the day? I don't know. Just I guess one last question I have for you guys before we end things off. What's the likelihood that someone in high school can get an internship at a NASA facility or someplace similar to that?
I've hired high school interns.
Mm-hmm.
We've had high schoolers in my branch too.
Yep. They're out
And
there.
if you saw a project like this, like even for high schoolers, that would
help you with the job. Yeah.
Wow.
So one thing I've noticed in Virginia for sure that is they have like engineering focused high school coursework as well. And they've got the governor's school as well. And I've mentored governor's school students. And then asked some of them to come back for a high school internship. So I am not familiar with any like engineering focused curriculum in Lincoln when I grew up in Lincoln. So something that was really cool to see here, and I wish that was available when I was a kid. But it's not necessary for you
Minnesota
to.
has some, not to dunk on your guys' state, but I am doing that.
Well, hey, it's not about dunking. It's about bringing everyone up.
Exactly.
Well, this
Say,
is
hey, don't dunk. You gotta say, hey, this would be a great idea for you guys to implement too.
well. This goal is. I just talked to a principal in a small town here in Nebraska about, and he asked, so how can we put this into the curriculum of middle school and high school? So this is the hope of the start. These folks are the foundation of what we hope to be an ongoing program here in Nebraska that will eventually lead to industry. And so that is the ultimate goal. And so again, we'll be turning to you folks to come home and lead that charge. We'll figure out how to pay you well. You can have all the eggs and corn you can eat.
Good old Nebraska.
I wanted to add for I'm not too sure about high school opportunities, but as far as opportunities at NASA, there was I think obviously kind of a joke on the chats here about not being an engineer. NASA hires a lot of people that are not engineers. So I just want to make that clear to all of you guys too, that we need people that are in the arts that do graphic design, because I talked about my flight mechanics modeling. What I see is not the Kerbal Space Program. I see lines and data. That's all I get to see. So I have to hand that information off to another person who then turns it into a graphic that can take CAD models of the vehicle and put that in, because especially for like higher ups or public outreach, like I can't show a line and say, look, this is how the trajectory looks. No one cares. So they want to see what the vehicle looks like as it flies, and then sensors doing things and stuff disconnecting or whatnot. They want to see that, and that's going to really hit home what's going on. So we need art people to do that. I can't. That's not my background. We need finance people to. Yeah, that's part of the communication. We need technical writers to help provide some people's engineering writing that isn't the best at communicating effectively what they mean. So there are technical writers that are available to help us adapt reports and papers. I mentioned the arts, the finance people, lawyers, doctors. I mean, it's a whole gambit.
Librarians,
archivists, teachers too. So there's a whole office of educational outreach. And I have partnered with them for going to schools and talking to people, and they put together handouts and resources for when people, engineers like myself, want to go talk to students at a school. They have all that material together, and it's very simple for me to just kind of go grab it and go, oh, this is great, and then I go present all that stuff to them. But I don't make that. We need teachers that make that kind of stuff. So there's a gamut of backgrounds.
Practically any discipline or field you can think of, technical or not, NASA has.
I kind of have a question somewhat along that vein, just in terms of graphics and what we should put in our presentation. You talked a little bit about a risk matrix, and I looked into kind of just briefly how to make that, and I've seen some like Excel tutorials and stuff like that. Would it be better to invest time in making good infographics, or would it be better to invest time in something else?
I would invest time in just getting the message out there first, concisely, and then you don't have to dress it up too much. I would just be concise and on message before getting into too much graphic design.
But if you can communicate an idea with a picture, people love pictures.
Okay.
I love pictures. I hate sides.
I love rockets.
Yeah. All right. Well, just so we don't stay too much longer, I guess. For the CubeSat team, this week we'll try and set up some meetings so we can kind of practice presenting a little bit more, as well as just change the slides around to match a little bit of the feedback we received today. I think the team would like to extend our thanks to Taylor, to Matt, to Justin. Really, you've contributed so much today that we would not have had access to otherwise. And hopefully it's going to allow us to really improve upon the presentation for next week and put together a really, a solid product.
Yeah, of course. And we expect you guys to do the same to the next folks who come along. So I'm glad that the UNL students are mentoring high school and middle school students, and that's really good to see.
Certainly, certainly.
Those are really cool guys. So you guys are doing a great job.
Yeah, good thing. You're doing all the right things. You're asking the right questions. This is so exciting.
And it seems like we say it every week, but seeing where we started out not too long ago at all, some of the presentations we were giving, and just all the research and knowledge we've gained throughout this process is really incredible to see. And just the type of work that the middle school and high school students have been doing matches and exceeds what I've seen like college peers do. So this puts all of us in a really good place going forward, individually and as a team. But hopefully kind of this week, we're able to make a little bit of a plan. And even though we're not able to meet at the SAC Museum next week, I think we're all really confident we're gonna be able to put something good together to present to some more folks down at Kennedy. But yeah, just wrapping things up today. Thanks everyone to coming. You know, the mentors we have, and as well as the students. But yeah, I think that's it for today. We'll make sure and get a lot of work done this week and kind of coordinate all of our efforts through Slack. Yeah.
All right. Thank you.
Yep.
Good job,
you guys have a good day.
Yep. You guys too.
for coming. Have
See you
good
guys
luck.
later.
And good luck.
Yeah.
You guys have anything you want to talk about?
I was gonna say, Joel and MJ, John, I just asked John over chat and he said he still wants to go see the SAC Museum today at like 1:30. So.
Which means that, yeah, you guys
Yeah.
will have to leave pretty quick. I thought that went really well. I mean, the nice thing is because we had this dry run, we know what we need to work on. And if we hadn't had a dry run,
Definitely.
I am typing up my comments and then the comments I heard, which I may not have captured perfectly. So I'm trying to look like at my, you know, when I'm hearing comments and then I'm trying to write notes and I'm finishing the other note and they start another comment.